YouTube channel. Naren here. We'll continue from where we left off last time. We were discussing section 5.2 right angle trigonometry. Last time we went through many examples and discussed a few problems. Now we will continue from here. We'll start from discussing some fundamental identities. So first of all, we will discuss reciprocal identities. Number one. What are reciprocal identities? So if we look back to the relations that we discussed last time here, so they have reciprocal relations with each other. Let's list them. What type of relation do they have? So sine and cosecant has reciprocal relation. What does this mean? This means sine theta is equal to 1 over cosecant of theta, or cosecant of theta equals 1 over sine theta. This also means or sine theta, if you multiply two reciprocal quantities, it gives you 1. So another illustration that when you multiply two reciprocal quantities you get 1 is you can take numbers. So for example, any number 2, what is its reciprocal? It's 1 over 2. When you multiply them out you get 1. Or say you have any number 2 over 5, what is its reciprocal? It is 5 over 2, and you get 1. So these are some these are the basic examples where we get, when we multiply two reciprocal quantities, reciprocal of each other, we get 1. Similarly, another relation is between cosine theta, and secant. So they also hold the similar type of relation. Sine cos theta equals 1 over secant theta, and a similar type of relations. Number third, tangent is reciprocal with cotangent. So they also have the similar type of relation. Cotangent of theta equals 1 over tan theta, and the other similar type of relations that we have here and here, they also hold a similar type of relations. So these are reciprocal identities. Number 2, we have are the Pythagorean identities. So in Pythagorean identities we have 3 identities. When you sine square theta plus cosine square theta equals to 1. So do not get confused here. Sine square theta, the meaning of sine square theta is you have a sine theta and you are squaring it. You do not write, this is wrong, okay? What if you write this? Normally in algebra, a times a is a square. Here sine theta times sine theta is not sine theta square. We write square over here. This is wrong. We write square in this fashion, sine square theta. This is correct, this is incorrect. So please keep this thing in mind. Similarly, we have another relations. Tan square theta equals tan square theta plus 1 equals secant square theta. Number second is 1 plus cotangent square theta equals cosecant square theta. So this. So I'm going to prove one of these. The other proofs are same. So I'm going to prove number A. So let's take left hand side and try to get right hand side. Normally, let's denote the formula for sine theta is opposite over hypotenuse. I will write opposite by let's say perpendicular p, these relations, recall these relations opposite by p, h, and these relations. Once you recall this, you can write this is an opposite and edge, hypotenuse. So and the relation between these two will be hypotenuse is equal to the square hypotenuse square. This is Pythagorean theorem. Hypotenuse square equals to sum of the squares of remaining two sides. So let's start with sine square theta plus cosine square theta. What is sine theta? So this is sine theta square plus cosine theta whole square. What is sine theta? Sine theta is p over h square. And what is cosine theta? It is adjacent over hypotenuse square. When you simplify this, you're gonna get h square, and when you further simplify it, you're gonna get h square. And using Pythagorean theorem, what I can see here is I can replace the top by h square and you get 1. So similarly, other relations also hold. So these are some reciprocal and reciprocal identities and Pythagorean identities. Number third is quotient identities. Quotient identities. These relations, the identity we are discussing right now, they are very important. So quotient identities are here. So tangent equals sine theta over cosine theta. Can you say similar expression for cotangent of theta, since they are reciprocal of each other? So this relation holds. You may choose to write it in different forms also, but we normally choose sine and cosine. Some people may argue that I can write this in this form. The relation, the sine is I can choose to write 1 over cosine, and then I choose sine's reciprocal is 1 over cosecant, and 1 over cosecant is a secant theta. So can't I write this relation? Yeah, you are correct, but we do not use this as a identity, because this boils down to the same relation, because sine and cosine are the basic functions. Normally we start studying from sine and cosine, so we will always use these two relations. These two are quotient identities. Now let's do few problems. Problem So first, given sine theta equals 15 over 17 and cosine theta equals 8 over 17, use the reciprocal identities, reciprocal and quotient identities, and quotient identities to find the value of tangent of theta and cosecant of theta. So solution for this problem. So we are given the problem clearly says, the instructions clearly says to use reciprocal and quotient identities wherever what is necessary. So first tangent theta. So we know that the quotient identity is sine over cosine. This is very straightforward. So what is sine? So 15 over 17 whole over 8 over 17. Now please look at this fraction. This is fraction of fraction. This is very important. I'm going to discuss this. Whenever you have a over b, fraction of fraction, you always, since we are dividing a over v by c over d, if you put multiply sign here, this becomes reverse. This reverses itself when you multiply it. So the formula becomes a over b times d over c. So another way of learning this is first over second times fourth over third. So normally we do that. So I will use the same technique here. 15 over 17 times 17 over 8. So 17 and 17 goes away and you are left with this 15 over 8. Very easy, very straightforward, very easy. Next one we want to find is cosecant theta, and cosecant theta is the reciprocal of sine. So is a reciprocal of sine. So just we can reciprocal it. It was 15 over 17, so we can directly write 17 over 15. 17 over 15. Or if you say you forgot to write in this fashion, say you choose 15 over 17 here. Now the same technique, this is 1, just one value here, this is not a fraction, so you can always multiply by reversing it and you will get 17 over 15. So these very important techniques. Another problem, given secant theta equals to square root 11 over 3, use appropriate Pythagorean identity to find tan theta. So this is also very straightforward. So tan theta equals what? We will choose such identity, Pythagorean identity from here. Since we are given secant, we will choose this Pythagorean identity. So what do we know? We know tangent square of theta plus 1 equals to secant square of theta. We will plug the values and just play with the numbers. So tangent is on the left side, so I will move all the other things to the right hand side. So tangent theta, tan square theta equals what is secant square theta? Secant is square root 3 over 3 square, right, minus 1. So this becomes 11 over 9 minus 1, which becomes, so you make denominators equal, 11 over 9 minus 1, which is 9 over 9, right? So which is 2 over 9. So this is square of tangent. So what is tangent? It can be plus minus 2 over 9 depending upon the value of, depending upon the wherever theta lies, it will have positive, negative. We will discuss it later, but for now whatever you choose, plus or minus, it's okay. Further you can simplify it to plus minus square root 2 over 3, because we can distribute the square root sign and hence. Now next thing we are going to discuss is co-function identities. Another type of identities, co-function identities. Now this is also very important because when you know the value of, for example, say sine 45 degrees or say sine 30 degrees, then it means you can also find some angle. If you know sine, you can find cosine, but not the same value, the different value. What is that? Let's try to figure it out. So first of all, these co-functions are defined only for complementary angles. So for complementary angle, so first this statement, cofunctions of complementary angles are equal. What does this mean? This means, so first of all, what are complementary angles? The sum equals 90 degree. For example, if you know cosine 30 degree, this means you know. So what is the angle complementary to 30? It is 60, right? So you also know sine 60 degree. They will be equal. This is their meaning. So similarly, if you know tangent 45, tangent 45, let's not choose 45, tangent 48. So what is the reciprocal of sine and here sine and cosine were complement co-functions of each other. Now for tangent and cotangent are co-functions of each other, so it will be cotangent 52 degree. And similarly, secant and cosecant are co-functions of each other. So for example, if you know secant 25 degree, it will be equal to cosecant. Now what is angle complementary to 25? It is 65, correct? So it will, this is how we find complementary angles. So in short, say if we summarize this story, sine theta will be equal to cosine 90 degree minus theta, right? If we subtract it, and the other way around, and cosine theta will be equal to sine 90 degree minus theta, or pi by 2, or pi by 2. Pi by 2 is 90 degree. So this is the relation we can generalize from the above the previous discussion. Similarly, whatever we have, the pair, this pair or this pair or this pair, we can extract the similar type of relations. So that I will leave up to you. And let's do a problem related with this. So given cosine 75 degree equals square root 6 minus 2 over 4. So this is given, we don't need to find this. Find a cofunction, find a cofunction with the same value, find a cofunction with same value. So first we will have to find, to solve this, we will have to find 75 plus some angle will be, so what is that theta? This is 15 degree, right? We subtracted, so it means and what are two pairs that are co-function with each other? Cosine is cosine is co-function, cosine and sine are co-function of each other. So this implies cosine 75 degree, whatever value we have here, equals sine 15 degree. So this is also value for cosine. So this is how we solve. So for today we will stop here, and we have further more problems on this topic, and we will come back, we will discuss this problem in next video. Until then, keep subscribing this channel, keep showing your support. Don't forget to like and subscribe my channel. My channel's name is Naren_ here. If you have any questions, please leave a comment in the comment box. Thank you so much. Have a great